let's see these integrals. So we are to test whether they converge or diverge. Converge or diverge. We are to test whether these two given integrals here converge or diverge. Alright, so this integral looks quite tedious, but it's so simple to work it out. So let's begin our work. Alright, so we have integral 0 to pi on 2 cosine of x over the roots of sine of x, or the x. So this is the given integral, and we have to test whether it converges or diverges. Alright, so here we know that from 0 to pi over 2, and then this function cosine of x over the root of sine of x, we can see that when x equals 0 here, our sine 0 is equal to 0, which will make this integral improper. So when x equals 0, the integral is an improper integral. So here, let's change the limit of the proper integrals, and using substitution, u equals sine x. Alright, so let's see. Let's let u equals sine x. So we know that the u dx is going to give us cos x here. Alright, so the u dx is cos x. Definitely dx will be equal to du over cos x. So we put this in the function there. Alright, so this integral becomes 0 to pi over 2 cos x all over the sine of x, the root of the sine of x dx. This will be equal to taking the limit as a approaches 0 positive here, because when we get 0, when it approaches 0, this integral will become an improper integral. Alright, so here we take a pi over 2, then the cosine of x all over the root of sine x dx. Okay, so here the limit as a approaches 0 positive here, of sine a 1 to 1 u to the power negative 1 over 2 du. That is when we use the u substitution here, because let me simplify it here for you to see. Alright, here we have pi over 2 0 cosine of x over, we know that this is u sine, let's u equals sine x, so sine x is u here, so we have u to the power of 1 over 2, then times du over cos x. Cos x will cancel cos x, therefore we are going to left with 0 to pi on 2 du over u to the power of 1 over 2. But we need to change the limit, because these limits are for x. We need to change this limit to u. So from here, u equals sine x when x is 0. Then we get u equals sine when x is a, because a is approaching 0 positive. So when it is a, we are going to get sine a, and that is the limit here. And then when x is pi on 2, we are going to get u equals sine pi on 2, and that is 1. Alright, and then 1 over u is the same as u to the power of negative 1 over 2 du. Alright, so we proceed. So here the limit as a approaches 0 positive here of 2, that is when we integrate this, we get 2u to the power of 1 over 2. Then take the limit sign a to what? 1. Alright, so when we put in the limit, we are going to get the limit as a approaches 0 positive or 2 minus 2 roots sine a. Alright, and this will give us, because a is approaching 0 positive here, this will all what? Tends to 0, and then this is going to give us what? A 2 what? So it converges at the point what? 2, or at the value 2. Alright, so let's look at II. For II, where we have the integral 2 to infinity 5 minus 3 sine 2x all over x squared dx. Alright, so looking at this function, let's 5 minus 3 sine 2x. Alright, we will know that this will be always what? Less than or equal to 1 here. So let's assume when we divide here by x squared, here 2 by what? X squared. So this function here is going to be less than or equal to this what? Function here. So let's assume this is f of x less than or equal to g of what? X. But we know that the integral from 2 to infinity of g of x, which is g of x dx, this integral converges at what? P equals what? 2, because we have g of x to be, that is 2 to infinity what? 1 over x squared, alright, dx. So by what? P test, by the P test, our P is equal to what? 2. Hence this integral what? Converges, because it is greater than or what? Equal to 1. So we say that this integral converges. And since what? G of x converges, it means that the whole integral, all this what? Integral also what? Converges. Alright, so that ends the solution for today's examples. Thank you for watching. Bye.